Hello, welcome to my channel. In this video, we are going to cover two blocks of Simulink Bus and Mux. Let's start with one set of data. I have four constants. Each is having a different value. Then, if I want to send this data, all these four signals together inside of the subsystem. What is the way? I have to create one subsystem. I have to connect all these four signals. Furthermore, if I want to take out anything from the subsystem outside of the subsystem, again I have to create multiple signals and take out. So the line complexity will be more. To avoid that, can we pack this as a one, and wherever needed, we can unpack it. So to do that, this packing and unpacking, we have two different blocks available inside the Simulink. One we call as a bus and another we call as a mux. Okay, if I start with the mux, what I have to do, I have to create set of inputs coming to this mux is a 4. So all 4 will get connected over here. Now these all 4 signals are packed as a one vector. So here if we see multiplex scalar or vector signal, it can combine all the, but the catch will be needed for mux is all these 4 has to be of same data type. When we are not giving any data type, it will inherit the same data type from the constant. Just in case if I select any of the data, so let's compile this, and this compilation is working, but for one of the data I'm going to change its type as, let's say, boolean, and the compilation should give me the error the data type is not matching. So when it inheritance start as a double, but one of the data is selected as a boolean, which means the different data cannot be accepted inside of the mux. So let's again inherit the profile, inherit from the constant value, and our compilation should work. This is the packing of the data that we are sending inside the mux. Now to unpack it, so when we want to use any of the data, we need to use the demux for it. So for the unpacking, we'll search demux, we'll connect our mux to the demux, and here we can define how many size this packing has to be split. So right now I'm seeing 2, and then I have to give one display just to see how this 2 split will work, what kind of output it will show. As we say, this is the vector or the scalar, but forms an array. So this array will get split. The most easiest way of split could be if I'm having the 2 splits on this side and the fourth set of data, it should divide the data into half of section, right? So let's do like this, and we will see 1 2 3 4. In case if we are only looking for one of the data, so let's say 2 or 3, this we want a separate data as a output from this vector, we have to create such split again. So how to make that split? Either we can make 3 split, just to try what happens. We will create one more. Now this is not the symmetric split. We have 4 set of data, but we are splitting into 3. Still, one pack has to have 2 datas, and then other 2 can have one data, right? So how does it make that split? It is still keeping first 2 data together, third and fourth got splitted. Then we have to make the 4. That is the one way. If our purpose was to extract out only the second data, this is how we can do. The other way could have been, I just make this as a 2 and then delete these 2 lines, just run. So 1 2 3 4. Now one more apply demux over here and just connect these two. And here this data will have that same value which we are looking for too. So this is how the mux and demux works for the same set of data. We will be going to change one data. So I'm going to create this as a boolean signal now, where the rest of the signals are already these three are double. To make this packing 3 as a double data type and 1 as a boolean data type, we cannot go with the mux or demux, but we have another block available which can be bus creator and bus select. So for that I'm going to give here as a 4, and let's connect all 4 signal. Here we have done, and then we should be able to compile and execute the model. Then to unpack it we have to select bus selector. If we see in a mux, we had no option to see what data we are sending. We are only giving the set of input parameters, but we cannot see the names of. So we are not able to preserve their data history. However, in case of bus, we can still see signal 1 is coming, signal 2, signal 3, and signal 4. So we have the history, which means the signal name can be propagated directly. And when we unpack it using the bus selector, we can specifically say that I want only signal 1 or signal 2 or signal 3, signal 4. So if I want only signal 4, I can only select signal 4, remove other two. So remove this one, then apply, and then add one display and just do this, execute. So with bus selector and bus creator, we can specifically select signal which we want to transmit whenever needed. If we see this comparison, in code we have two different data types, structure and the arrays. Let's go for time being into the C++ code. So I have already written a code for the struct and array. Here I have array where I'm creating three arrays, different arrays. One is having names, all has to be of same data type, so string, all these are the string. Then I'm creating another array for the int data type, and third I'm creating for the double data type. And when I will run, I will be running as the array name and the index of it. I don't have the information own identity of this data, right? I cannot directly access ABC with its name, but I have to go for the array name and then indexing of it. So if I run this, you will see programmer 1 information name, age and grade, and then ABC. How do we printing? Because we are having the array and its index. However, in terms of structure, how do we have to do this? So I'm uncoding this part and then this part, and then let's comment out this. So after running this, I'm having name, age and grade. Here when I'm trying to access the structured data, I can access its a name. So this is a signal name which is preserved in the structure definition. So whenever I will try to access name, I can directly say programmer dot name, which is the same case in the Simulink also. Bus dot signal 4, and that's the value we are getting. Bus dot signal 1, bus dot signal 2. So bus is giving us an advantage that we can preserve its value. We will not lost it. However, in case of mux, we will lose its name. It's a history of the signal name. We will be only able to access as an index. This is the first index, second index, third index, and fourth index, like that. So this is the difference in structure and the array. Now the question comes then, when should I go for the bus and when should I go for the mux? So let's understand in this way. I have created a small table for the comparison. If I want to work with a mixed data type interfaces, there is the only option that I have to go with bus. Mux doesn't support for the mixed data type interfaces. If I want to preserve the history of the signal name, so which signal I'm propagating, if I want to use it in the next level of the subsystem while transmitting, I have to go for the bus. But if I'm okay with only with the indexing value, only its value, that this particular index is having this value or not, if such condition I'm having, I can also go with the mux. If I want to create a same data type with just as a vector, then yes, mux is okay. But if I want a structured container, something like this is the structure which I want, then I can go for the bus. So these are the difference between the bus and the mux. And when you will design your model based on set of data, based on the purpose, you will be able to take your decision whether in this case I should use a mux and demux or bus creator and the bus selector. Hope you like this video. Thanks for watching. See you in the next video.